I'm Sourav Sachin. I'm DOE for Flipkart, and my topic is scaling with unconventional tech stack. That's nodejs plus redis plus mongodb. So let me first start this conversation with scaling, like why scaling is so important to understand. So let me have a quick show of hands. How many people have heard about Flipkart? Have a quick show of hands?
I shopped today.
Great, great, good to hear that. Okay, how many people have shopped from Flipkart? Okay, great. How many people shopped from Flipkart 1 year earlier? Okay, so you can see the difference, right? You can see the difference. So scaling is something that just hits you when you're not really expecting it, with that overwhelming proportion. So that's why scaling is very critical to understand. It's not the average load that you have to be prepared for. You have to be prepared for peak load, and that's what makes the whole game very interesting. And why I mentioned unconventional is because Node.js is making its inroads, but it's still not the mainstream technology. So we all are pushing forward to see how real applications can be done with Node.js. So this is what we'll go through. We'll first understand the requirement, what we wanted to deliver, followed by what went wrong with our choices. And then we tried some experiments and had some fun out of that. After that, we realized how certain things function, and then made some even wiser choices, and then finally the chosen ones, what tech stack we used and what node modules. So first of all, our requirements. So before I put up all the points that we had to decide on what requirements are, this was done at my previous engagement, where there was a consumer-facing product which already had 65 million users, and we were trying to get many of them onto this app. So this was a mobile app, and this is the backend that we were trying to develop for that mobile app. So the scale, right from the first day, you can anticipate that once people start moving, it'll be a huge scale that will hit your system. So first of all, we wanted the setup to penetrate through restrictive environments like banks and office networks. Then we wanted some very open standard to be followed, so that is widely interoperable. And then we also wanted to make a choice of language, so that development is easy, we can easily find resources. And then we wanted to find some open source project which can be the base, and we start developing on top of it. So these were our answers to these requirements. Penetrate through restrictive environments like strict banks and office networks, of course HTTP. And then open standard, widely interoperable, XMPP. I think most of you might be aware XMPP is the protocol that Google uses, that Facebook uses for their IM connectivity. And the language, the conventional Java, I would say, now as the mainstream. And open source project which we chose was OpenFire. So this is an XMPP server which does, which is written in Java, so extensibility was pretty easy for us. But the challenges that we faced, first of all with HTTP, there were no issues. It perfectly served its purpose. XMPP, it was too chatty for the bandwidth sensitive mobile app. The problem with it is not just the bandwidth. When we use the bandwidth on a mobile app, it also consumes a lot of battery, and that's not something which is acceptable to people. And then we had very inefficient ways, very inefficient ways to handle frequent reconnections. But in mobile app, you can't help it. You move from place to place, your IP connection definitely breaks. In Java, we didn't have much problems with that. Reasonably fast development, resources are easy to find. OpenFire, again, we had some problems. It wasn't scaling. There's some special way to deploy it. It's called federated deployment. But to do that, it had very demanding needs. So we couldn't go ahead. We couldn't continue with that. So now we started our experiments. Quick prototyping of different ideas that we had. So one of the things that we tried, Nginx is a well-proven front end for many of our applications. So Nginx also comes with this interesting Nginx push stream module. So this is exactly opposite to how PubSub works. It pops up, subscriber they hook up to the channels which publishers have, and then publishers write and it reaches all the end customers. Here it's exactly opposite. We tried this, it didn't scale well, so we moved forward. Then we tried Node.js. So when we were experimenting with Node.js, our initial prototypes were very quick. So we were quite happy with that, the way things were proceeding. We knew we have to do a lot more for scaling, but still it was quite fine. But the challenge was that most of the JavaScript developers, their JavaScript understanding is all need-based. They go open some site, most of them are front-end developers, they open some site and then they realize, okay, let's open source, see it, read it, what it is doing and learn from that. But that was not enough. We needed to have more discipline. So this is the point at which, in fact, Rakesh Pai is the guy whom we associated with. So So he also gave a couple of talks. He has given one talk, he'll be giving another one. So he's the guy whom I ensured that will be bringing in the discipline and the coding. Now, then we had few other challenges. Like when you deploy, then in a typical deployment, you have a load balancer and you have a lot of machines where the load is balanced. So there is a situation of socket starvation. I'll quickly explain that. So what essentially is a socket? So if you see a socket, with these 5 parameters, you can uniquely identify what a socket is, right? So those are your source IP, destination IP, which is in the IP layer. Then you have the type of socket, the type of packet, that's also in the IP layer, followed by which you have source port and destination port in the transport layer. So what your OS does very beautifully is that OS actually abstracts all of these things out into a nice FD, a file descriptor, which any program can easily handle. So, and a typical deployment will look like this. This is your load balancer, which does NATing. When any connection comes from the internet, it uses up one socket on this side to rewrite the packet so that it reaches one of these machines, which has an instance of your application running. So the challenge here is that this IP that you see here, for example, 192.168.22.1, this one. So you can only have 65535 number of ports, 16 bits basically, which is therefore your port number. So how will you handle when you have more requests than that? If your application was put up right here, imagine this web server was here, then what happens is the source IP changes, or at the least the source port changes here. So those sockets are still unique, right? So those sockets are still unique. But when you come to this kind of a deployment scenario, now the challenge is that this IP is fixed, right? This is masked from the real IP of your other users, of the clients which are actually connecting. So then this is where socket starvation happens, because you're using up one socket of that load balancer. So then we came up with a very interesting idea that we named it uranium because we didn't know when it will explode. So that was the project nickname. So this idea was that instead of using up a socket in this model, we'll actually expose these ports. We'll expose these ports on which these services are running, and we'll actually be doing 302 redirect. So that is, there's no socket that goes waste. So yeah, in this project, we try to do that. But interestingly, later on we figured out that the load balancer, now they have come up with very advanced features where you can do IP pooling. So we could do IP pooling on this side, and hence conserve our socket. Not conserve, but now we have many sockets to use because these are all private IPs. Okay, then we wanted to we experimented a little bit with node cluster also. With node cluster, if you recollect the previous slide that I talked about, OS is actually abstracting out all the complexities of your network connection and exposing it as a very easy to handle FD, file descriptor. So node cluster, essentially what it does is that it takes that FD and then passes it on to one of the instances which it has spawned. So now here the thread which is actually handling, which is picking up that FD and then passing it on to the next ones, that becomes the single point of failure. And we wanted something which could scale horizontally, meaning we could just keep adding more boxes and scalability shouldn't be a question. So again, node cluster we had to drop. Another interesting learning was the testing setup. So we started the conventional way. So we had all the JMeter and a lot of other things installed, and we tried to attack these services with the conventional ways. So interesting thing was that our servers, they were very happy because there wasn't enough load, and the client machines which were trying to put the load, they all starved of resources. So that was very interesting finding. So now we thought what to do. How do we achieve a good testing environment which can really put adequate stress, and we know what is the capacity of this whole system, this whole deployment. So then finally we ended up writing the entire test setup also in Node. So that was a pretty interesting exercise, and that was successful. So what did we finally choose? So these were the final tech stack that we ended up having. So for application layer, we had nodejs. We also used pub/sub of redis, which is pretty powerful. Initially, we were thinking of writing it ourselves, but then this redis, the benchmarks and all the things you see, is phenomenal. So we ended up choosing redis as our pub/sub layer. Also redis for caching of session, where we were doing all verification of session tokens, etc. For persistence layer, we had mongodb. MongoDB also comes with JavaScript-like interface, so it was pretty friendly to the developers. Then we also had process monitor. For that we used Forever. Forever is also written in Node, by the way, so this was pretty interesting. Forever did process monitoring, meaning if it's like Watchdog. So if the process dies, then it respawns the process. If the process dies too frequently, then it has some configurations which can restrict that how much time to wait before the next spawning of process happens. So we experimented quite a lot with many different modules, node modules, and this was the final list that went in the deployment. So Express.js, you guys can do that. That's the URI router. So when you put a URL, it reaches the server. Then from there, it figures out what the URI is. Like for example, here /a/luca.com like that, and then it knows which particular function to call. So that's how Express was there. Then config, this was used for configuration management. So, this offered us to run very efficiently to move very efficiently from dev environment to staging environment to a production environment. Mocha was a very interesting thing that we got introduced to. So this is the BDD framework, the behavior-driven development. So Mocha uses the should, that's the last thing. So this has a lot of syntactic sugar that it adds. So the test scripts are very, very readable. It's very easy. And if you have a product manager who wants to see that what all tests have actually happened, it's very easy to generate such reports. And then we had Mongoose. This was the object document model. Object document map. Then we had Optimist. This was used equivalent to getOps, like how you have command line arguments. So you want to process them, you want to store them, and then move forward. So we used Optimist for that. Node redis. This is a redis driver standard. We had to make a lot of HTTP outbound connections because I explained that we already had a consumer service which was running, which had 65 million plus users. So we had to do authentication and a lot of other things depending on different services. So we needed to make a lot of outbound HTTP connections. That was handled through this. And should was a Mocha dependency. So there are a few references. These are things that really helped us get on this speed. There's one introduction to Node.js with Randall. This is a YouTube video which you guys can check out. Now when we tried Mongo, this was a pretty interesting exercise because most of our developers, they had relational background. Relational meaning the RDBMS background. So when they switched over to Mongo, their thinking was still like relational. So we were essentially creating tables equivalent in Mongo, and then we were trying to find what relations exist, which was not the right way to do it. So then this was the video, one of the videos that we saw, and this was quite interesting because this changed the way we were thinking about things. So this is how to think non-relational. It was pretty good. And then we have this redis, which has pretty well published documentation. Yeah, so any questions that people may have now, let's take that. And we can go back to different slides to elaborate. Yeah.
So what is the timeline attached for this prototype? Like it's quite a lot of features and a lot of work involved. So how much time did you take to achieve this? And just to figure out what are the things that just to understand the efforts involved.
Sure, this is a very good question. I would love to answer this one. So the first prototype that we did actually took us 3 days. The first prototype, but of course it wasn't scale ready. There was tons to be done. So not the entire research. The first prototype is that much. And then the total thing, I think, took us 16 weeks, around 16 weeks to get to the first cut. Yeah.
And in 16 weeks, it was production ready, right?
Yes, first cut in the production. Okay, I'll do that next one.
You talked about the Redis and MongoDB. Both of them are NoSQL data stores. And I believe Redis is also has got its own persistence mechanism there too,
yes.
And one is snapshotting and one is append on file.
Yes.
So is there any reason why you choose going with MongoDB as a flag persistence mechanism and not choosing
Sure.
Redis?
Sure. This is a good question. So his question is that Redis supports persistence any which way, so why did we choose MongoDB for our persistence layer? So yeah, one data correction, Redis, it's not NoSQL. redis is just a key value store, and little more than that. Not little, quite more than that in other aspects, like it has features like pub/sub, it has queues and those things. So it's not NoSQL replacement. So redis supports something called bgsave, which is a very smartly developed feature. This feature, what it does is that whenever there's I/O bandwidth free, whenever the system notices, that's when it actually dumps. That's when it dumps the stuff to disk. That's yeah.
It also supports another command as of 2.4. I believe that's what you will be using. Write error that does have background event only file. So I just believe that Redis's persistence mechanism is a lot more robust and a lot more quickly to add on.
Okay, so his point is that Redis has few other features like append only thing. So come what may, but Redis is not a replacement for NoSQL. We had many more features, right? So MongoDB was essential for us. So we did think of using bgsave, but because MongoDB was anyway in place and all our persistence was happening there, we thought of keeping it unified at one place. It made analytics and everything else easier.
Yeah.
This gentleman here.
Yeah. I have a question here. You said about load testing that you did it in stress testing in Node itself.
Right.
So there are a couple of things. I have two questions. One is, can you elaborate more, in what sort of load testing using Node, with the conventional JMeter or something which you are not able to achieve, and which Node allows you to do that. And second one is, we talked about horizontal scaling. So Redis, I think, how do you as far as I know, as in clustering in Redis is still in a very infant state. I don't know if it has improved, but so how do you cluster Redis or in your non-relational database?
Sure. Okay. So the question is that how did we achieve horizontal scaling, right? And the second part is that how did we achieve that with Redis, right? So let me talk about the app first. So in horizontal scaling, we were actually running different instances of app, and there was a machine which had 16 cores, so we ran 16 different instances of Node. We had another load balancer. That load balancer was doing NAT, the previous slide that I showed, but it was doing NAT with a pool of IPs. So that helped us in having as many sockets as we needed. Yeah, this one. So each of these machines, they were running as many instances of Node.js, as many cores we had. And this guy was configured for each of those instances independently. So whether this instance is running on machine A or machine B, irrespective of that, this guy could comfortably do round robin across them. Earlier, the project that I talked about, Uranium, there we had thought of very interesting ideas which could also check the load on a system. Like say if there's one client which connects to a specific instance of Node. So we don't know about the life of this connection. If the life is very short, then probably that connection gets counted, whereas the load on that system is not as high. So to achieve perfect load balancing, we tried on that project Uranium, but then this load balancer had enough features to suffice for it. So we finally didn't go ahead with this Uranium thing for our load balancing. So we went ahead with this model only. But here we had to ensure that we had pool of IPs here, using which the NAT was done, and it was helpful. So now you could just add up more machines. If these number of machines are less, then you could add up more machines here and run as many instances as the number of cores are there, and then just configure this load balancer to take care of that. So that's how we achieve this horizontal scaling. And about Redis, so for Redis, we were running two different machines which are relatively high end, and they were running Redis, and it was kind of load balanced. So that's how we manage things. So yeah, of course, Redis clustering is something that we were experimenting with. So I'm not sure what the current state of the project. Yeah.
So when we say two Redis instances, so that's like in slave of one?
Yes, one active at a time. Active passive, yeah.
Okay.
Yeah,
and, one last question.
Sure.
Flipkart is open sourcing some of those tools.
Yes.
I've heard it in many years.
Yes.
Yeah.
We are very active contributors to open source, and there are a lot of other Node related projects that are happening. You'll be seeing them on open source pretty soon.
Yeah, so the question I have is, I didn't get what would the use of this, like what is the use case where this gets used? What part of Flipkart are we talking about? Where is there need for a persistent connection between the client and the server?
Uh-huh.
So it was not very clear.
Oh, the use case. Okay, maybe I did not explain it enough. So the use case was, this was an application which was done where there was a mobile app that we were developing. So the mobile app had to connect to a backend for private chat. Like the way you have Gtalk, for example. So you can have an iPhone, an Android, and all of them, they can communicate. So we dealt with the backend part in this presentation. It was a front end also. The front end was, there were native Android apps, native iPhone apps, few hybrid apps. Yeah, they could all converse. Any other question? Yeah, somebody there.
I don't think I need the mic, but anyway. So, do you mean that this system that you wrote is not actually part of the cloud?
Yeah, that's right. Is it part of Flipkart? No, the one that I talked about is not part of Flipkart. It was a part of my previous engagement. At Flipkart, we are doing very interesting stuff with nodejs, which will come up pretty soon. Was the end deployment.
Hey, so great session, Arvind.
Thank you.
One thing, I heard that nodejs, I may be wrong about this, but not good for applications which are IO extensive.
Yeah, so I think in one of the previous talks also Rakesh talked about this. Situations where Node.js is a very good choice and places where it's a terrible choice. So anything which is very CPU intensive, you must stay away from Node.js, of course, because it's not designed for it. It's evented thing. I'll cite one very interesting example. There was one MySQL driver which was not asynchronous. So you would make a request and all the other connections, these are all FDs, right? So say if you have maybe 20,000 FDs, which this Node.js instance is handling, and now there's one of those connections which needs to go to MySQL database and get some information back. All these other threads, all these other socket connections are stuck. They're stalled till it gets back the stuff. So you essentially have to have asynchronous driver for everything. So there are a lot of precautions to be taken. So that's why I talked about discipline, which is pretty important. Yeah. It allows a lot of flexibility. Prototyping is really quick. You don't have to worry about concurrency, but you have to stay disciplined. Any other question? Okay, thank you.